have not tackled that class. So please let us start with that class. And the next class that we are supposed to tackle is now what you call learn technology. So if you look at the notes that I sent, I had sent all the steps that we are supposed to follow in planning the network. And still I sent an assignment that we are supposed to do, but most of you have not done. So I have only one assignment. I have received one assignment. So please, can you do that assignment? Maybe to gauge what you are understanding about the planning. But I want to have a recap on what you discussed because of time, so that we can go to network technology. So if you look at network planning, the word planning means organizing or steps that you are supposed to follow in order to come up with your network management. And if you look at in day-to-day activity, we always look at planning as a way of managing and organizing the way activities are supposed to be done, one after the other. So the same case when you look at the network planning, we first of all understand that we must be able to understand the network that we are supposed to have. Are we having a LAN or a WAN network? And if you are having a LAN network, so it means the planning is requires few resources. If you're using one, it requires more resources. And that's why we need to look at, first of all, looking at the factors that we need to consider. And if you look at most of the factors that we need to consider in a network, we always look at one of them being security. And that's why when you are looking at the security that you are supposed to have within the network or within the organization, when you take an example, maybe you are given an organization to set a network. First of all, you need to look at the security of that network. Maybe we need to look at the location, or we need to look at how the organization is located, or how many users are within the organization. Then we still need to look at now the type of topology that we can use within that network. That's why if you look at the network planning, we first of all do what you call gathering requirements. And when you do some gathering requirements, we are looking at the factors that we need to consider in order to make sure that there is the right network within the organization. That's why we are saying one of them is to identify the nature and the volume of data. And that is now the key one, because now if you use the network, one thing is the data that you need to consider. Then you have to determine how the network will be used. So how many users? So in this case, we are looking at now the topology, or we are looking at the number of users that are supposed to use the network. And maybe we can decide the types of devices that we are supposed to have. And these types of devices that we are supposed to have, one of them, and I remember I said a computer is not a device. So we are using bus, maybe switch as a device. We are using repeaters, and we are using routers and many other devices that we always have within the network. Then we can decide maybe the type of usage level. Remember, if you look at the network that we always use up to today, we have the network level, and the network level is always given by defining the network bandwidth. And the network bandwidth that we are supposed to discuss, mostly it's catered by the server that we are using. So how will you position the server? If the server is supposed to hold 20 users, so you should not exceed that. And if you look at the topic that we are supposed to cover, where this topic is not examinable in NEC, you look at subnetting. And when you look at subnetting in detail, we always understand that we have to understand the number of users that we are supposed to have within the communication. Then, if you look at the data gathering, of which you have looked at the factors that you need to consider, that's when you select the topology. And the topology that you are supposed to select, I know that you understand different topologies. And mostly, if you are looking at topologies in wireless, I remember I explained few of them, where we said one of the topology that we have is distributed, and the next one is what? The next one is what? So which is the next topology that you can use in a wireless technology? Remember, we have two technologies. We have wired and we have wireless technology. So if you look at wireless, one of them is distributed. The next one is what? Carry, can you answer that? The next one is what? Are we in class? Are we in class? So you can use either messaging or if there is an issue, please can you raise the issue before we continue? So which is the next? Okay. So if you can hear me, what is the next technology that we have? Because we said one of them is distributed. And when you're using distributed network technology, which is the wireless, then the next one we said is centralized. And if you look at the wired technology, there are various topologies that we use. One of them is LAN topology. We have, the next one is what? We have mesh, bus. So mostly for LAN, if you are using the wired technology. So that's why we are saying, we first of all look at the type of the topology that we are supposed to use. And we have to select this topology. Mostly we use LAN, and up to now, you know what are the function of a LAN. Because when you're using LAN, we are looking at a very small network, which has a good security within the organization. So first of all, you need to look at the number of cables that we are supposed to use. Maybe you can look at cost, we can look at the network size, maybe the equipment that we are supposed to use in order to do that. Then after that, you can conduct survey. And when you conduct survey, it means that now you're understanding the nature of the business. Mostly we need to look at where are the sockets, maybe where are the devices located, how will you phase out the devices that we have. Maybe we need to use horizontal way, or we need to use vertical presentation. So all these are now the survey that you take within the organization. So I expect you, maybe if you're given a job, maybe to do in a given organization, you're not rush directly to installing the network. First of all, you must gather the information, you look at the topology, then you look at the survey. Because when you look at the topology, mostly it will give you the size of the organization. Because you cannot say that the organization has 5 users and then you are using maybe 1. Automatically, it is very costly, which now leads to some cost, which is not good. The next one is capacity planning. And when you look at capacity planning, you determine the network bandwidth. Remember, up to now, we still look at the bandwidth. And the moment you are looking at the bandwidth, we are looking at the frequency. So that is what we say, the frequency. The determinant is how many megabits per second are we supposed to transmit within a given cable. Let me use cable or Ethernet. Remember, we always use 100 Mbps, but in some cases, there are those that nowadays we are using maybe 3 Mbps, 6 Mbps, and many others, depending on the size of the network that you want to have within that organization. So in that case, you cannot say that now you are having 6 Mbps and the organization is doing some processing. So remember, if it is doing some processing, it requires a lot of bandwidth. So that is when you have to look at which type of bandwidth, which type of capacity planning are we supposed to engage within the organization. Then the next one is creating the baseline. So mostly when you look at this step that we have capacity planning, we are looking at now creating the baseline of the network that we have. And the baseline, we are looking at now, for how long will this network work? So if you look at nowadays networks that you always have, we say it's 1 month. Now, but now if you look at most of the organization, we can say it can work for 2 years. Maybe it can work for 1 month. It can work for 2 days. If you look at now in that. And in this case, if you want the network to be to be okay or to be perfect, where we say it's efficient network, we always look at now using different devices or various devices. Now we can use maybe the routers, bridges, switches, hubs, etc., and the servers. It's not like when you're using tethering with your mobile phone, which does not even require much of implementation and statistics for us to create some implementation of the network. So you find that now, if you want the network to run for a long duration or for many years, you have to implement these servers that can hold the connection path that we have within the network. Then the next one, which is very important, is designing the network. At the moment we are designing the network, now you have to look at various tools that you can use. And I always say that one of the tools that you can use Visio. And Visio is one of the best device or tool that you can use to come up with the designing of the network. It's like now, if you are given a work to do in a network, maybe you're installing a network in an organization, you first of all have to come up with what you call a blueprint. You present the drawing that you are supposed to have, or maybe how the computer is supposed to be laid out. And that's why we are saying it's useful question to answer before drawing the diagram. And one question that you need to ask is, how many client computer will be attached? So how many computers? And how will you know that you are having 10 computers or that? So in this case, we are looking at the bandwidth. And the moment you look at the bandwidth, the first case that you are supposed to understand is that you need to look at the network class, the class that you are using. You know, there are those classes that doesn't allow more than 10 people. There are those that allows more than 50. There are those that allows more than 1,000. So you have to look at now the class that you have within the network. So that's why if you are given an IP address, maybe I'm given an IP address 192.168, maybe 0.4, 0.3. So you must understand this is class B. And if it is class B, because you always understand that class 0 to 27, that is class A, 127, sorry, 128 to 192, that is class B, then 193 to 223, that is class C, then 224 to 239, that is class D, and the next one is now class E up to 254. So in this case, there are many users that you can have. So we need to look at this. You need to do what you call subnetting. And the moment you are doing subnetting, it's now coming up with broadcasting signals. Then you come up with a server. So we can assume this is the server. This is the IP address for the server. But given this, you must know how many networks are we supposed to have. Maybe that's why we can say maybe we are having 24. And we are supposed to have 32 bits. So you must be able to reduce 32 minus 24, which becomes 8. And when it becomes 8, those are the number of hosts that you can have. So you can say maybe 2 to power number of 8. So you try to come up with how many hosts are we supposed to have within this network. So in this case, that's why we need to look at the number of clients. How many users do I have? Then how many servers do you need to attach? It's not a must you have 2 servers. You can only have 1 server. But that server, it must be secure enough. It must be good enough to support the network. That's why we don't see looping of the network or fluctuations of the network. So fluctuation of the network comes when the server is too weak to hold the network capability. The fluctuation of the network comes when we don't have a good security. So we must cater for those problems that we have. Will there be a connection to the internet? Obvious. If you are coming up with a connection with the network, you must use some connection of the internet. So most of the students, they don't have a clear definition of what is networking and internet. Remember, when you network is not interneting. Network is an internet of internet is a network of network. So the first thing is to network. Network means organizing, logical, physical organization. Interneting is logical organization, meaning when you network, you can now allow connection of the network of the internet. That's why we can use the internet, because we have already identified the server which can hold the connections, or which can do what you call distribution of the network. Remember, we said we can use one protocol, which is called DHCP, Dynamic Host Configuration Protocol. And then we create the network, the internet. That's why we can be able to lay out the connection. So network and internet are two things which are totally different. Networking is laying out the network. Internet is now connection over the internet that you are supposed to serve, or the data that you are supposed to use in an organization. So how will the building physical architecture? Remember, if you look example, and I'm using a rectangle building, so automatically we find that there are some issues in the connection. And if there are issues in the connection, we find that we cannot have a very clear connection within them. So in this case, we can say most of the connection that you always use, we must know the building. So if it is circle, we must use some connections that are circular, because we are not supposed to lay out the cabling in a manner that the users will be resulting to insecurity or accident within the organization. Then the next one is to ask yourself whether we are using wired or wireless. So if you are using wired, which are the connections that you're supposed to use? If you're using wireless, which are the connections that you're supposed to use? Then after that, you look at the topology. So designing is one of the important activity that you're supposed to do when you are documenting the network layer. Remember, this is the one that now defines how the network will look like. There is a way, like now, if you're using electricity, you can connect parallel or in series. But the moment you are connecting in parallel, now you have to ask yourself, will the first bulb affect the next bulb that you are having? If you're using series, if one bulb is off, always the second one will be off. That's why we always connect in parallel. So that is why we are saying network design is one of the important features. So this diagram is examinable in NEC. Please, can you note this? It is examinable in NEC. And I hope we are together. Okay, Kiari, I will repeat that when you are creating the baseline. And if you look at these notes that we have talked about, remember we have said when you select the network and then you create the capacity planning, you must be able to know how the network will be able to operate. And when it is operating, it is supposed to operate maybe for 2 years, for 3 years, for 5 years. If it is supposed to operate for 3 years, 5 years, that is when you need to look at the devices that you can use to support that. And that's why if you look at the next one, we have looked at the devices. After creating the baseline, you must know the devices that you are supposed to, because this network, I'll use it for 2 years. Maybe this one will go for 1 month. It's like now the network, the third party that we use currently, if you're using the third party, automatically it goes for 1 month, which is charged maybe 3,999 or maybe 2,999 or 1,500. So that is now the baseline. And that's why we are saying you can allow the designing, because now you know the time that you are supposed to run the network. And that's why we are saying this is examinable in NEC. And please, I have not seen it for a while, so I'm assuming maybe you can see it in your NEC exam, that is July, where sometimes we always look at the network development life cycle. So all those gathering that all those steps that we have looked at, they are now looked at by this structure. And this structure solves the problems of accessibility. And when you are solving the problem of accessibility, now we are saying we are now summarizing this. Because now we have designed, we are now summarizing designing in a network. And the first one is to analyze. And I think analyzing is not new to you, because when you're analyzing, you are correcting some, we are defining some problem. And when you define the problem, we are coming up with the objective. And we are coming up with the objective of the network. Yes, I have already designed the network, but what are the objectives of this network? The objective of this network is doing processing, learning, and many others that we are having, maybe messaging and many others. So you have to look at those. That's why we are saying a network cannot provide cannot provide effective solution to problems that have not been clearly defined in the objective term. To attempt the implement network before everyone agrees. So before you implement the network, you must look at the objective. What are the objectives of the organization? The objective of an organization is to do processing. So I must look at those. So that's why before you buy the network, or before you say that now I'm buying this network, remember I have now laid out the networks. The cablings are okay. The computers are okay. But now I don't have internet. Now for that, you need to look at now, for you to come up with the internet, you need to look at this structure. And when you look at this structure, you must now liaise with the vendors. You buy the network. When you buy the network, that is when you are doing what you call analyzing. And there are key factors here. And one of the key factors that you need to look at is you need to do these 4 things here. And mostly, we are looking at these 4 things to the vendors who is providing the network to your organization. 1, interview the users and technical personnel. So how will the network operate? You know, you can go to a certain vendor, but the vendor has some weakness. The network has some weakness. And because the network has some weakness, you'll always be having some fluctuation in your network. Maybe you are doing some processing. There are raw materials that are supposed to be processed. If there is no network, the system goes off. Automatically, you lose millions of money. So you need to look at interviewing these personnel. How will they operate? So we are understanding now the technical goals for the new or enhanced system. So you need to look at now how the organization will work. Characterize the existing network if you have. It's not a must you have the existing one. Maybe you are starting your business. So you can be able to look at the existing if you have it and the current one, which is good. So you can learn them in parallel if you have already been given that. So please, Kotut, if you are asking a question, you are allowed, maybe to use a mic. I have seen a question. Does physical and logical topology be applied in network planning and designing? Yes, this is the one that we are looking at this point now. It is applied. If you look at physical, this is when we are talking about organizing the computer. And remember, in the last topic that we were discussing, we were discussing a topic on designing. You design. When you're designing, this is when you are coming up with a structure. You say this is a network, computer 1 will be here, computer 2 will be here. We will be using vertical or we will be using horizontal. So in this case, how many computers will be sharing the cabling? Or how many computers will be sharing the network, the first move of the network? So in this case, we are looking at the physical. But now the logical is when we are looking at this point, which we have said we need to use the IP address. And when you look at the IP address, in most cases, when you look at the IP address, remember there is a point where in designing, we said we need to look at the IP address that you have. So this is now defined as a logical organization. And when you look at the logical organization, you have been given the IP address. Remember, the IP address can be given in terms of your names, can be given in terms of your presentation. Please, just a minute. I respond to this. Network here, and this network that we are having in this painter, we can assume we are having a server here. Maybe this is a server. So if this is a server that we are having here, and then you are connecting to various computers. So if you are connected to this computer, maybe this is 1, this is 2, and this is 3, then I have another one here where I can have 4. Maybe I have another one, I have another one. This is 5, and this is 6. This is parallel. So when I'm using this connection, I'm using what you call the physical design. I'm using the physical design. So I would like to give you maybe an assignment, a takeaway assignment, maybe for your own benefit. Maybe try to download Visio. Visio is an open source software. And this open source software, you can use it to draw some presentations. So try to come up with a structure of maybe about 20 computers. How will you lay out those 20 computers? Maybe if I'm using this. So this computer and this and this and this and this and this, it is using the network from this server. So if this server goes off, now you have some issue. That's why you find that when the power goes over, there is what you call looping. There is what you call looping. And looping is always catered by, if I can use this page, is always catered by an IP address 127.0.0.1.1.1, or we can use 0.0.0.0. So this is used for looping. Looping means to regenerate the signals, regeneration of signal. And regeneration of signal comes when the network was off and it goes back to the starting point. And when it goes back to the starting point, now you have to restart again. And when you restart again, that's when you find that when the power was off and then it has started working automatically, you find that now the network is too slow, then it is speed up the execution. So in this case, that's why we are saying the logical organization must be effective. You must know how to organize. If you organize computer 1 is connected to computer 2, if computer 1 maybe loses the network and the second one will lose. So you need to look at each and every computer as its own design in that connection. So that's why we are saying the specific technology and product to realize the logical design are selected. The investigation service provider must be completed during this phase. And which are these factors that you need to look at? Most of these factors that affect this design is what? And I think I asked this question, and it's only one person who did that. Please, can you do that assignment? It is graded, and please let us do in the due time. I think the deadline was today. Please do it before the day ends. If it is the deadline is today, I will extend up to tomorrow. So one of them, you need to look at the size. If the network is too big, and I will ask a question here. Suppose you are using your mobile phone. I'm asking a question. Suppose you are using your mobile phone, and you know that the network is it always allows 5 users. If I try to add another users, okay, there is a person who is saying can't see the illustration, still stuck at word. Okay, let me see the issue. So I hope now you can see. So I hope you can see this now. Is it okay? Ikonyo, Tony Ikonyo, is it okay now? Okay, I'm sorry for that. I'm sorry for that. I'm sorry for that. I will repeat the design that I was talking about. Maybe I can use a new one. What I was saying, when you are connecting, you must use a server. So this is a server. Remember, this is a network that has been connected somewhere from either fiber optic cable, maybe you're using a wired technologies in that. So if this is the building, and we are assuming this is the building here, and maybe your computers are supposed to be arranged in this way. So if this is the first computer, and this is the second computer, and this is the third computer, and we have another computer here. Now, what we were saying is that this is what you call the physical organization. And this is what one of you have said is a physical topology in connection. That is the organization of the network. So if this is now, you need to ask yourself, how are these computers are supposed to share the network? If we share this, and we say this computer will be sharing this, that's why you find that most of the users uses what you call a switch for you to connect that. Remember, when you are having a switch, automatically if computer one fails, the other one is still okay. If this one fails, the other one is okay. If this one fails, maybe this one is okay, and this one is okay. If this one fails, it will not affect the other communication. That's why we were saying that is the logical the physical organization. And in the physical organization, what we have said is that we must use some factors here. And one of the factor is, remember here how many computers? These are 6. Suppose we require 50. Now, size depends. And when you talk about size, because the size is now depending on how many computers are supposed to be connected in this. Now, that's why I was asking, if you have your own computer, and this computer, if you have your own maybe phone, and you want to share, where we understand that the maximum number of users are 5. Now, how will the network be stable? Will you have a stable network if you are connecting the 6th person and we are only around 5 people? Will you have a stable network to other users who are connected before you? No. Okay. Okay. The answer is no, because now it keeps on fluctuating. Remember, we lower the bandwidth for others. We are trying to accommodate the 6th person where it is not applicable. So in this case, that's why we are saying the size of the network depends. So if the network size is too big, now you have some issue. That's why we are, at the end of the day, the size does matter. Size does matter, mostly. Designing a LAN for a small office with a few users is difficult from building one for a large company with 2,000 users. So in this case, if you employ somebody to do that, if you're employing to do that, and you are the one who is connecting these users, automatically, my friend, you have to ask a lot of money, because now you must configure to each and every computer. And when you are configuring that, it requires resources. So in this case, we still require some cost if the network is too big. So you need to look at geography, and I think this one we have looked at. Mostly we need to look at building, Maybe we need to look at where the network is coming from. We need to look at the experts that are connecting. Maybe if you are using the tariffs, maybe how much will I be accommodating within a month? And that's why we are saying the decision-making process for selecting a right technology and equipment for remote connection. So you must look at the geography. Like now, if you go to up country, not even up country, let me go to central. Maybe I go to Nyeri. We know that those towns that are closest to Mount Kenya or that are closest to the mountains, automatically we have some issues of the network. So you must look at that geographical coverage. Now, if you look at the wireless technology, if I can look at the wireless technology, if you go to Nyeri and I am at Nairobi, the network is stable in Nairobi, but the network is not stable in Nyeri. So those are issues that you always have. So the network is affected by the nature. The network is affected by the climate. The network is affected by the surroundings. So we are looking at the geographical coverage, which is affecting the network connection. So in this case, that's why we are saying we need to look at the geographies that are connected to it. So you need to look at how the network is supposed be within that. Maybe politics, then the next one. How many departments? So we can talk about politics. This is not the politics that you always have. We are looking at the number of departments that we are supposed to have. We always understand that if you go to most of the organization, we have different departments with their own small networks. Sometimes we call personal area networks, but in this case, we can call it campus area networks, CAN. Meaning, Department A can share with Department B, Department C can share with Department E, but maybe there is a department that is not even sharing the network. Now, the question is, if I am having 3 departments and I say Department A will never share with any other department, what am I looking at? One, I'm looking at the security, meaning that this is a vital document that I have within that department, so I don't want to share the network. Because the moment you share a network, it allows the user to intervene on the usage of that network. So I can crack on, I can be able to hack the system. But when I'm using my own network, the private network, so automatically there is no issue. That's why we are told if you go to your matatu and you're using the Wi-Fi, my friend, can you switch it off? Because you might be working with somebody who is trying to hack you. So it's always important when you are in a matatu or when you are in a public gathering, make sure that your computers or maybe your phone is switched off because you have vital documents. So we always understand that because of security issues that we have within the network. The same way when you're using the Bluetooth, switch off the Bluetooth. We know that it uses a thickness of 11, the size of 11 megabits per second. So in this case, it can still be affected. That's why we are saying you need to look at politics in that. And that is now how will you organize this network? Maybe in departments, maybe we can organize IT with business, maybe business with looking at the usage of the network. How will I use the network? Maybe if I go to business, I want to use network. I only use the network when maybe I'm sending mails. When I go to IT, I'll use internet when I'm submitting mails, when I'm teaching, maybe when I'm doing any other things that I'm supposed to use. So you need to look at that. But Keta, mostly what you need to look at is the security. The next one is the type of application. The type of application deployed determines the bandwidth required. Or the text-based transaction may require a few kilobytes per second of bandwidth. Remember, when you're using multimedia, the same case when you're using video, it requires a lot of networks. We cater for that. When you're using videos, I can use maybe 200 Mbps, megabit per second. But when I'm using data, like now I'm sending mail, I can use 1 KB or less KB. So in this case, we have to look at that. So this is mostly the IP address, and I think I will be able to set a class for the IP address that will be able to work with the IP address, maybe to come up with how many classes do we have? Just for an explanation, because I will not explain it today on how to subnet. I will be able to explain with some examples maybe next time, because we have only one topic that is remaining. This is where we look at different classes. And the different classes that we always have determine the number of users that we are supposed to have within the network connection. It is still determine the purpose of it. Like now, if you look at class D and E, E is used for experiment. D is used for research. If I want to do some researching, I use class D. And that's why we have said, if maybe I use a PowerPoint here, we can say maybe we are having a class A and we are having a class B. I hope you can see that. So if I'm using a PowerPoint here, I can say I'm having a class A. Class A is supposed to move from 0 to 127. Then the next one is class B, which is supposed to move from 128 to 192. Then the next one is class C, which is supposed to move from 193. This one we can say up to 191. Let's say up to 192, 193 to 223. Then we have class D, which is supposed to move from 224 to 239. Then the next one is class E, which is supposed to move from 240 to 254. So those classes depend with the number of users. One, we are looking at users. The second, we are looking at the type of connections. So I'm looking at class A, class B, but the type of connection we are having, or the purpose. Maybe we still need to look at the purpose of that connection. So those are the factors that we need to look at: number of users, type, and the purpose. So in this case, that's why we are saying in most connections that we are supposed to have, we need to look at the IP addresses. And when you look at the IP addresses, we are looking at the network and the host. If you look at class A, how many networks do we have and how many hosts do we have? If you have class B, how many networks do we have and how many hosts do we have? So in this case, if I'm using the IP address, maybe we can have an IP address like this. If you look at this IP address, it is in class A. It is in class A. So this is network, but the whole of these are the hosts. If you go to class B now, it divides into two. These are the network, these are the hosts. But now you'll not be having 172, you'll be having 190 something, 193, 194, 195, 220, etc. If you go to the next class, you have only the hosts are these, but now you leave about that. So in this case, we are looking at now where we can look at the number of users that we are having within the connection. And those number of users that we are having within the connections defines how it will be used. So what we are supposed to cover on network, I'll reach at that point, because now this is more of subnetting. I don't want to do subnetting today. Maybe we can set a day that we can do subnetting, but before that I will send some videos that you can watch first so that we can do some netting. And there are various ways of doing subnetting. One, we have fixed subnetting, we have variable subnetting. Remember, when you are using fixed subnetting, this is when you can use manual way of interpreting that. Variable, they can be able to vary or change in different levels on that. So up to now, let us first of all reach at that point, and then you can ask a question. so that I can introduce the next topic. And the next topic is land technology. Is there any question on that? Any question on that? Please let us communicate. So I hope Gekonyo, we have Kiari, Evans, Mushangi, and Muraya. Please, can you communicate? Please, can we communicate? We are allowed even to use mic. We are still allowed to wave. Maybe if you can wave, if you have video, you can still wave. Okay, so I have, okay.
Do you understand? Unasema nini? Eh?
Transisio. Wewe, sawa sawa sawa.
So I hope now it is clear. Okay. So what I'm saying is when I'm using these technologies or LAN technologies and WAN technology, so we are using the networks that we have. And those networks that we have, there are some factors that we need to consider. And one factor that we have said we need to consider is the cost efficiency. So we need to use less money to install the network. We need to use installable network. Remember, we have said we cannot use a network that we cannot be able to pay. We need to use an internet the way in the way that we can be able to pay it. So mostly that's why we said we need to look at the organization that we are installing the network. So for this case, if you look at the presentation of these networks, that's why we need to use different technologies in that. And most of these technology, one of them is the token layering topologies. And I have said this is not new to you because when you're looking at the ring topology, we always use it the moment we are connecting to it. And that's why I was asking a question. When you're using token ring topology, how does it work? So that's why I was saying maybe somebody can explain to us, how does it work? How does the ring topology work? The token ring topology works. When you're using the token, how does it work? Please, can you answer that? If you are able to answer. Or if you're not able, you can say maybe I explained to that. Are we able to hear that? Now, how does it work? Murai, I think you're okay now with the mic. So how does it work? Okay. So I have seen each node connects to exactly 2 other nodes. It's okay. That is now the physical laying out of the ring. By the moment you are using a token, so what we say about the token, it revolves around the network, waiting for a computer to connect to it. At the moment a given computer takes the token, automatically it now does what you call encapsulation. It does what you call encapsulation. And encapsulation is bundling the messages, what is supposed to be sent, the IDs, and maybe we have the packets. We call it the packet. At the moment we connect that, it revolves around looking for a computer that is supposed to receive it. The same case to this, because we are saying it is a LAN technology. So one of the devices that we use in LAN technology is the token ring, where it passes the mechanics for eliminating contention. What is contention? If you look at LAN technology, we said we can only reduce contention, and contentions is the bandwidth loss, attenuation, distortions of the messages, etc. And the way we said we can be able to reduce this or we eliminate these is by one, we can use what you call token. We can use what you call carrier sense multiple access with collision avoidance. Then carrier sense multiple access with collision detention. Those are 3 main methods that we can use to reduce contention, to reduce loss of signals within the network, to reduce attenuation, to reduce distortion, to reduce jittering of the networks. So in this case, that's why we are saying, if you look at this topology that we are having, maybe you are using LAN topology, we are using LAN token, carrier sense multiple access with collision avoidance, carrier sense multiple access with collision detection, and I want you to research on this. How does it work? How does carrier sense multiple access with collision avoidance works, with collision detections works? So please, can you research on that? So because now we are understanding that the ring moves along the ring and looking for a computer that is supposed. So it's trying to reduce some contentions within the network. And that's why we are saying there are actually two standards for tokering. It was originally developed by engineers at IBM who created the initial specifications subject to that. And most of these specification is 802.5. These are the ones that we always call them Ethernet. So if you can now summarize that, we are using cable ring connection. And that's why we need to look at the topic, which is not in your syllabus, which is called Ethernet. We need to look at Ethernet. And the moment we are looking at Ethernet, we need to look at Ethernet in terms of the standards. We need to look at Ethernet in terms of standard. 802, maybe 0.11a, maybe we have 11b, we have another one, maybe 0.12, 802, maybe 802.12, etc. And those Ethernets comes with different functionality. Mostly one of them is the speed. The second one is the security in terms of how secure is it, in terms of efficiency, how efficient can it transmit data from one point to another. So in this case, that's why we are saying we are looking at the Ethernet communication, which was developed by IBM. IEEE is an engineering standard. It's a standard. This is a standard. And this standard is the one that now approves these Ethernets. It's the one that approves this Ethernet. So the moment we will be talking about Ethernet, we will be able to look at now what is IEEE, what is IUNT as a standard for approving that. It's like now we have the ISO as a standard and other standard that we have in this country or in the world. The next one is the Fddi, Fiber Distributed Data Interchange, and this is the one that works in LAN technology, and it's mostly used as a backbone. And the moment I talk about a backbone, you understand that it's like when you're using a bus topology, the way it communicates. And we say that it has a high speed Ethernet technology. So can you see we are using Ethernet? So that's why we need to discuss. The next topic will be Ethernet after we discuss what you call the WAN technologies, And mostly what we are looking at here is that this one is using fiber operations or fiber technology in transmitting data. Fiber option or fiber technology in transmitting data. And in this case, we are looking at a point where it has a very high speed during transmission. It has a very high during transmission. And because it works efficiently in communication than the token ring, so we say it is more efficient. So we can say it is efficient. And when you talk about efficient, it's able to work with the confinement of the resources given. It is high speed, so we have a high speed. Then the next one that we can say, maybe the cost. What about cost? It is high cost. We understand that the fiber optic cable has a high cost. And I think you have seen a fiber. Have you ever seen a fiber? Maybe home fiber. I know most of you are using home fibers. Have you ever seen a home fiber cable? Maybe we can have some answer on that. Okay. So yes, so if you look at that home fiber cable is of a high speed transmission. And because it's of a high speed transmission, that's why we are saying it uses this technology, which is called the fiber distributed data interchange as a technology. But it works together with what you call a synchronous transfer mode. Remember we have said like a synchronous transfer mode, choice for the RAN backbone. This one now was implemented. Fddi was implemented after ATTM because of the speed. And that's why we need to discuss it somewhere here. We are saying a synchronous transfer mode is an adaptable technology that can be used in LAN and WAN. Remember now, if you ask a question, which are those technologies that you can use in both WAN and LAN? One of them is asynchronous transfer mode, where it was used as an integrated service digital network. Now, I know you are familiar, or maybe if you're not familiar, maybe those booth. For those people who used both, I know most of you have never used both because your age does not allow that. So in this case, we were using what you call asynchronous communication or asynchronous transfer mode. And that's why before you communicate, you must maybe trigger a certain event by using a coin, maybe 5 bob. So when 5 bob is over, automatically it ends that at that point. So it used what you call write transmission, and this write transmission is when you're using service digital networks or a synchronous way of communication. That's why we are saying it used both what you call switching technology and multiplexing. So I think up to now, you know different types of switching. So somebody can answer that. How many types of switching do we have? Maybe you can name one or two, at least one. One types of switching. Remember we have said that ATM uses switching technology. And if you look at the topic that we discussed on switching, now you can be clear to understand how this technology works. Maybe I have explained with that booth how it works. One switching, one switch. Okay, packet switching, yes. The next one. Okay. We can exhaust that. We have packet switching, message switching, and then we have circuit switching. So in those switching, that's why we are saying they both work on this LAN and WAN technology. That's why we are saying it was able to use both modes, WAN and LAN technology, and multiplexing. So up to now, you know the purpose of multiplexing. And we said the purpose of multiplexing is when you are providing different paths of communication, but they must follow either in one route or in one path. So it's like we are having 10 users, but these 10 users, they must transmit bit in one line of communication. And if you look at this, it uses 53 bytes. My friend, if you look at 53 bytes, these are too small in communication. And we find that now it is a fixed size cells. And when you look at the fixed size cells, we must say it has to be in a given limited time of communication. And if you are looking at bytes, we are looking at maybe a character, presentation of a character, in presentation of that. And it was able to transmit, of which it was okay in transmission, but to hand a high speed still, but the speed, it was not high than Fddi. That's why we implemented Fddi after the ATM. So you can say the first one was token ring, the second one was ATM, the next one was Fddi. And then after that, maybe we started using others that we can use as X.25. And X.25 are other technology that you'll be able to discuss in other technology. So we are saying it was originally conceived as a high-speed transfer technology for voice, video, and data over public networks. That's why we had an invention of now using the mobile phones for communication, because we can still say the mobile phone uses ATM technology in communication. That's why if you look at mobile, let me explain a bit on the mobile phones, the way mobile phones works. And if you can look at how the mobile phones works, we always say that the mobile phones is made up of cells. And these cells are of 5 ends. I don't know how you can call it. I'm not a mathematician. 5-sided, is it the pentagon? How many what? Is it pentagon? 1, 2, 3, 4, maybe 5. 5-sided.
Pentagon.
Okay. I'm right. I'm not a mathematician. So we can say if you're using 5-sided, we can now have another 5-sided here. Allow me to count as I move. 1, 2, 3, 4. Allow me to change that to that, please. I'm not clear with these diagrams, so you can at least understand. 1, 2, 3, 4. 1, 2, 3. Okay, we have another one here. So we were supposed to have another one here. So where we can draw here, and maybe we can draw here. So if you try to look at this, 0, 1 and 0, 2 is able to communicate. So 0, 1 transmits to 0, 2. So in this case, we are using what you call a synchronous transmission, meaning this one is transmitting to this, the other cell is transmitting to that, the other one is transmitting to that. That's why we find that when you're trying to call somebody, mostly it has to go to the base station. And when it goes to the base station, it must of all look at the cells that has been created for communication. The same case when you're doing what you call roaming. And I think in your mobile phones, you have a term that is called roaming. Roaming in mobile phone means when somebody is communicating in UG and you are in Kenya, does it mean that when I go to UG as a Kenyan, I will change my mobile phone? No, I will not change my mobile phone. I will change the tariff, and maybe here I'm using Uwezo. Here I will not be using Uwezo because maybe in this country we don't have Uwezo, maybe, which is determined by the tax. So if tax is high, I think Tunisia has the highest tax rate. So if I go to Tunisia, automatically I will be charged higher than in Kenya. So sometimes that is roaming. So roaming means you can be able to communicate inside and outside the country, sorry. And that's why we are saying, if you're using a synchronous transmission, you must be able to allow a very fast communication as a LAN technology. And that's why we are saying it uses voice. So how will you know that when I'm communicating, I will be able to reach to you? So it will keep on telling you that somebody is waiting for that call. And that's why it links. When I'm using video, right now I'm using videos. So there is that connection that I'm using. Maybe you can see me, I can see you. That is another asynchronous transmission. That's when you say, in this switching, it uses one type of switching that we call time division multiplexing. Remember, we have how many types of switching? How many types of, in switching, we have said we have packet switching, we have message switching, but in that, we can use circuit switching, where we say we have time division multiplexing. So in our case, we are saying it uses circuit switching automatically. Moving changes from one switch to another, as the way I have explained on these cells that I have here. So I think in that, you can be able to understand that when you are using this technology, we use switching methods, or we use switching technology. That is moving from one point to another time, because we have to limit time in communication. And that time that you limit in communication, it will assist us in managing how a cell is able to communicate to another cell. Another cell is able to communicate to another cell, etc. Are we together in that? So you can, I have sent those notes, and still maybe we can be able to research on that more. Remember that question is still examinable. I have never seen a question on that. I'm expecting a question on that. So in 2 weeks to come, I will be able to tell you where we can get some questions for NEC, and we familiarize ourselves in that, so that now when you go to the exam room, you will be able to know more on that, or you'll be able to answer the question. Do we have a question up to that point? Do you have a question? Nothing. So I'm sorry for that. There is an issue with the network. That's why I was trying to check on that, please. Is there any question? I think I have received a question. I have received a no from Kerry, Muraya, and Evans. Bura Faith, I think you have joined. Bura Faith, eh? Am I able to communicate with Bura Faith? So Mushangi, please, can you tell me whether you are okay? You can talk, huh? It's good even. Okay, please, eh? The video still I will send, of which this video has some issues, because now sometimes we have some issues of the network, but it is okay for what we have already tackled today. Please, you can still listen it afterwards, so that you can maybe understand what I was talking about. And then after that, remember, please, can you do that assignment you said before the day ends, please, for marking? Please, can we agree together? Will you be able to send that assignment, please? Then the next one that we are supposed to look at, and those ones I will send, which I will start with it next week. And then I will start with that. Then we go to learn technology. Then after learn technology, So I think I have recorded, I have resolved that. Carrie, I think I have resolved. So I think I'm now clear. So I'm saying, can we move to the chat room? Because I want us to have a quiz that I want us to do 5 minutes. Maybe we can do that quiz. It's not hard, so that we can get to know how we have maybe understood these topics, these 2 topics that we have covered. Can we move to quiz? So I'm expecting 6 students to do this, please. Muraya, is there any question? Can we move to the quiz? Mushangi, Gura, Evans, and Kerry. Gekonyo. I think I have gotten an answer from Kerry. We can move. Okay, let us move to that point. So, and I appreciate for listening. And please, next Monday, please, can we wake up early? I know it is on Monday. Please let us wake up early. I don't have a time limit. Even if you tell me to start early, I can still start. So please let us move to the quiz. I will set them. And those quiz, you'll find them in the second topic where we have notes for learn technology. So please let us move to that point. Okay.